Good morning, all. Hope all of you are well. So, in the yesterday lecture, we have completed the length of belt drive. Then we have find the ratio of driving tension between tight and slack side, and then we have find out the relation between the ratio of tight side and slack side and angle of contact. So today we will try to solve some numericals related to the power transmission of the belt drive and the length of the belt drive. So here you can see there is one numerical in which it is written two pulleys, one 450 mm dia and the other 200 mm dia are on parallel shaft 1.95 meter apart and are connected by a cross belt drive. Find the length of the belt required and angle of contact between the belt and each pulley. What power can be transmitted by the belt when the larger pulley rotates at 200 rpm if the maximum permissible tension in the belt is 1 kN and the coefficient of friction between the belt and pulley is 0.25. So firstly we will make the diagram. Suppose this is your driver pulley and this one is your driven pulley. Now belts are connected with the help of cross belt drive. So in case of cross belt drive, we have the arrangement like this. So here this is the first pulley, this is the second pulley. So the speed of the dia of first pulley is 0.45 meter. Dia of this driven pulley is 0.2 meter. We have converted mm into meter. And the distance between the center point of these two pulleys is 1.95 meter. Basically, we use the sign x to denoting this center distance. Now, firstly, we have to find out the length of the cross belt drive. And the length of the cross belt drive is given by the formula pi by 2 d1 plus d2 plus 2 times the center distance between the two pulley centers. Then d1 plus d2 square by 4x. Now almost all the things are given. Pi by 2, d1 is 0.45, d2 is 0.2 meter, x is 1.95, d1 is again 0.45 plus 0.2 whole square divided by 4 into 1.95. And after calculating this value, we get the length of the cross belt drive is 4.977 meter. So similarly, in the numerical, the question can come like this. You have to find the length of the open belt drive. If the pulleys are connected with the help of the open belt drive, then you have to use different formula. So only the sign here will be changed. This equation remains same, but here we get the d1 minus d2 over 4x instead of d1 plus d2 the whole square. So next thing which we have to find out. So angle of contact between the belt and pulley. Suppose this is the center point, and suppose here you have the angle. This is the angle of contact between the belt and pulley, theta. Now to find this angle, we know if this angle is theta, and let us suppose this angle is alpha. So all of us know for a cross belt drive, the sine alpha is equal to R1 plus R2 over X. This equation we have already derived in case of the length of open well drive. We can also write 2 times D1 plus D2 by, sorry, yeah, 2x. So sin alpha becomes D1 is 0.45 plus 0.2 D2 divided by 2 into 1.95. So alpha is sin inverse 0.65 divided by 2 into 1.95, and alpha values come 9.6 degree. So this is the value of alpha. Now next thing is we have to find the angle of contact value theta. Now theta is equal to, for cross belt drive, theta is pi by 2 plus, sorry, 180 degree plus 2 alpha. Further, to convert it into radian, we multiply it with the pi by 180. So theta becomes 180 degree plus 2 into 9.6 pi divided by 180 degree. So by calculating the whole values, the value of theta becomes 3.47 radian. So this is the value of angle of contact. So next statement is, what power can be transmitted by the belt when the larger pulley rotates at 200 rpm if the maximum permissible tension in the belt is 1 kilonewton. So all of us know the maximum tension in the belt is the tension in the tight side. So this value. So suppose here we have the tight side, here we have the slack side. So the maximum tension here is 1 kilonewton equal to 1000 Newton P1. And the coefficient of friction is also given 0.25. So we have to find the power transmission. So power transmission will be given by, so we take the another page, blank page. Sorry. Here we will have the black page. Black page. So the next thing is we have to find out the power transmission by the belt. The power transmission by the belt is given by the equation T1 minus T2 into velocity, where T1 is the tension in tight side and T2 is the tension in the slack side, and V is the velocity of pulley, either driver or driven, in meter per second. So here to calculate V, we have the formula pi D1 ny 1 by 60. So it is already given in the equation. The rotation of the pulleys are larger pulley 200 rpm and larger pulley diameter 450 mm. So we can use here pi into 0.45 200 rpm divided by 60. So value of the velocity after calculating is 4.74 meter per second. Now we know T1 over T2 is equal to e raised to power mu theta. T1 is given 1000 Newton. T2 we have to find out. Mu is given coefficient of friction, that is 0.25, and theta we have already found out 3.47. So the value of T2 will be 1000 divided by e raised to power 0.25 into 3.47, and this value comes as 419 Newton. Further, the power transmission will be T1 minus T2 into V. That is, the value of T1 is 1000. T2 we have just calculated 419, and the value of velocity is 4.74. It comes out to be 2740 watt, and we can also write it as 2.7 kilowatt. This is a way we can solve the numerical based on the power transmission by the belt. If the fundamental things which are given to us are the like the type of the belt drive, that is the cross belt drive, then diameter of both the pulleys, then the central distance between them, one of the tension is given, then RPM of any of the pulley is given, and the coefficient of friction is given. So this is about the how we can solve the numerical. So stay updated for the my next video. So please like and subscribe my channel on YouTube. I will post lot of videos related to the education as well as the motivational point of view. Thank you very much.